Welcome to the first lesson in our series on ship construction. Today, we'll be delving into the world of engineering drawings. These drawings are the blueprints that guide the construction of ships, from the initial design to the final assembly. Think of engineering drawings as a map that shows the ship's structure, dimensions, and components in detail. By understanding these drawings, we can visualize the ship's form, understand its construction methods, and ensure that it meets the highest standards of safety and efficiency. In this lecture, we'll explore the different types of engineering drawings used in ship construction, learn how to read and interpret them, and understand their importance in the shipbuilding process. I'm Dr. Sam Taufik, and I'll be your through this exciting journey into the world of ship construction. Let's get started. Before we dive into the technical details of modern shipbuilding, let's take a quick trip back in time. The Egyptians were among the earliest shipbuilders, with the oldest known pictures of boats, dating back over 6,000 years. These ancient vessels were long, narrow, and made of papyrus reeds. They were propelled by rowers using paddles. While these boats were simple in design, they laid the foundation for the development of shipbuilding over the centuries. Today, ships have become much more complex, but the basic principles of design and construction remain the same. In the next part of our lecture, we'll discuss how engineering drawings play a crucial role in the modern shipbuilding process. When engineers design a ship, they create detailed drawings to visualize the different aspects of the vessel. One common type of drawing is the isometric drawing, which shows the object from three different perspectives. As you can see in the shown figure, an isometric drawing has three main views. Plan view or top view. This view shows the ship from above. A bird's eye view of its overall shape and dimensions. Side view or profile view. This view shows the ship from the side, revealing its length and the arrangement of its various components. Elevation view or cross-section view. This view shows a vertical slice of the ship, giving you a look at its internal structure and the arrangement of its decks and compartments. By studying three views together, you can get a complete understanding of the ship's design and how its different parts fit together. When creating blueprints for a ship, engineers use different types of lines to represent different parts or features. These lines are like a code that helps builders understand the design. Let's look at this image. It shows the main types of lines used in construction drawings. Thick continuous lines. These lines represent visible edges or outlines of objects, like the outer edges of a ship's hull. Thick dashed lines. These lines indicate hidden edges, or parts that you can't see from the outside, such as the internal structure of a ship. Thin continuous lines. These lines are used for dimension lines, which show the measurements of objects. Center lines. These lines represent the center of symmetry of an object, helping to locate its center point. Cutting lines. These lines indicate where a section or view of an object is taken to show its internal details. Now, let's focus on the right side of the image, where we see examples of how these lines are used to represent different shapes and objects. Circular pipe. Hollow. This is represented by a thick continuous line for the outer edge, and a thick dashed line for the inner edge. Circular bar. Solid. This is represented by a single thick continuous line. Square pipe. Hollow. This is represented by thick continuous lines for the outer edges and thick, dashed lines for the inner edges. Square bar. Solid. This is represented by thick continuous lines for all four sides. By understanding these basic line conventions, you can begin to interpret engineering drawings and visualize the three-dimensional structure of a ship. When building a ship, we start with basic steel components that are shaped and joined together to form the vessel's structure. One of the most fundamental components is the plate. Imagine a flat sheet of steel, like a rectangular piece of metal. This is a plate. It's the most common shape of steel used in shipbuilding. Plates come in various thicknesses depending on their specific purpose. Plates are used throughout the ship, forming the hull, decks, and other structural elements. They provide the ship with its strength and rigidity. Now that we understand the basic concept of plates, let's explore a specific type, deck plating. This is the steel plate that forms the main deck of the ship. It's the surface you walk on when you're aboard a vessel. As you can see in the image, deck plating covers the entire upper surface of the ship. It's a crucial component that provides a strong and stable platform for the ship's superstructure. Now that we've discussed deck plating, let's move on to another essential component, shell plating. This refers to the steel plates that form the outer skin of the ship's hull. There are two main types of shell plating. Bottom shell plating. This is the plating located on the underside of the ship. It's further divided into inner bottom plating and outer bottom plating, depending on its position relative to the double bottom structure. Side shell plating. This is the plating that forms the sides of the ship. It's the part that you see when you look at the ship from the side. Now that we've discussed the main components of a ship's structure, let's talk about the elements that reinforce and support these components. These are called stiffeners. Stiffeners are strong sections attached to plates, bulkheads, and beam webs to prevent them from bending or deforming under the stresses of the ship's operation. They're like the ribs of the ship, providing additional strength and rigidity. As you can see in the image, there are several different types of stiffeners, each with its own unique shape and function. Some common types include flat bars. These are simple, flat strips of steel. Angle bars. These are shaped like an angle, with two legs that meet at a specific angle. T-bars. These have a T shape, with a vertical leg and a horizontal flange. Half bulb plates. These have a rounded shape on one side and a flat side on the other. Bulb plates. These have a rounded shape on both sides. The choice of stiffener type depends on the specific requirements of the structural element being supported. By carefully selecting and placing stiffeners, engineers can ensure that the ship's structure is strong enough to withstand the forces it will encounter at sea. Now that we've discussed stiffeners, let's move on to two other important structural elements, girders and floors. Girders are vertical, longitudinal members that run along the length of the ship's bottom. They're like the backbone of the ship, providing essential support. There are two main types of girders. Center girder. This runs along the center line of the ship's side girders. These run along the sides of the ship's bottom. Floors are horizontal stiffeners mounted on the ship's bottom. Unlike floors in buildings, which are horizontal surfaces you walk on, ship floors are vertical structures. They're like transverse beams that connect the center girder to the side plating, providing additional support and stability. Together, girders and floors form a strong and rigid framework that supports the weight of the ship and ensures its structural integrity. Now that we've discussed girders and floors in general, let's focus on a specific type, solid floors. A solid floor is the simplest type of floor to construct. It's essentially a solid plate without any holes cut into it. These holes, called lightning holes, can be used to reduce the weight of the plate and allow for better fluid flow in tanks. Solids are often used to divide a larger space into smaller compartments, like different tanks within a cargo hold. They provide a strong and rigid foundation for the ship's structure. Now that we've discussed solid floors, let's explore another type, plate floors with lightning holes. Unlike solid floors, plate floors have holes cut into them. These holes reduce the weight of the floor, which is beneficial for ships because lighter ships require less fuel to operate. However, cutting holes also reduces the floor's overall strength. Plates with lightning holes are often used inside tanks to provide additional support, while allowing fluids to flow freely within the tank. The holes help to reduce the weight of the floor without compromising its ability to withstand the pressure of the fluid. Now that we've discussed solid floors and plate floors, let's move on to the third type, bracket floors. Bracket floors are the lightest of all floor types. They consist of a relatively short bracket connected to the center girder and extending towards the sides of the hull. Between these brackets, there are short stiffeners shaped like a T at the top and bottom of the space. Bracket floors are used to provide some stiffening between the plate floors without adding too much weight. They're a lightweight and efficient way to reinforce the ship's structure. Imagine a large, hollow box made of steel plates. To make this box strong and sturdy, we need to add internal supports. These supports are like the bones of the ship, giving it structure. One of these important supports is called a vertical beam. Think of it as a tall, standing pole that runs from the top to the bottom of the ship. It's like a pillar that holds up the weight of the upper part. In this image, we see a cross-section of a ship's hull. The vertical beams are the lines that go from the top to the bottom. You can see how they work together with the other parts to make a strong and stable framework. Now that we've discussed various structural elements, let's explore the concept of brackets. Brackets are connecting plates used to join two or more structural elements together rigidly. They're like the joints or connectors in a building. As you can see in the image, there are different types of brackets, each designed for a specific purpose. Some examples include built-up T-section. This type of bracket has a T-shaped cross-section and is often used to connect structural elements at right angles. End bracket with flange. This bracket has a flange, or a flat, projecting part, that extends from one end. It's often used to connect structural elements at an angle. Stiffened web frame. This type of bracket has a web, or a vertical section, that is stiffened with additional plates or sections. It's used to provide extra support and rigidity to connections. Brackets are essential components in ship construction, as they ensure that the various structural elements are securely joined together to form a strong and stable vessel. We've covered a lot of ground in this lecture, from the historical context of shipbuilding to the various components that make up a ship's structure. I hope you've gained a better understanding of the engineering principles behind ship construction. Remember, engineering drawings are essential tools for visualizing and communicating the design of a ship. By mastering these drawings, you contribute to the creation of safe, efficient, and innovative vessels. Thank you for your attention. With my best regards, Dr. Sam Atawfiq.